What's up guys, I'm back with another video and today I'm going to be playing with some numbers. This is a new series on my channel which is about maths. Today's topic is prime factorization. Prime factorization can be in two parts, prime numbers and factors of a number. Prime numbers are numbers that can be divided by 1 and itself only. One example of a prime number is 7. 7 can be divided by 1 and 7 itself. And let's take a look at a non-prime number. For example, we have 9. 9 can be divided by 1, 3 and 9. 7 can be divided by 1 and itself, so it's a prime number. 9 can be divided by 1, 9 and 3, which is not a prime number. Now let's take a look at factors of a number. Factors of a number are numbers that can be divided by that number. So now let's take an example as 8. So 8's factors are 1, 2, 4 and 8. So we can exclude 1 as it can divide any number. And let's take another number, 9. It can be divided by 1, 3 and 9. So we can again exclude 1. As we can see that 2 from 8 and 3 from 9 are prime numbers because they both can only be divided by 1 and themselves. So we can say that 2 from 8 and 3 from 9 are prime factors. Now let's take a look at them. Prime factors of a number are prime numbers that can divide that number. So as we saw, 2 is the prime factor of 8 and 3 is the prime factor of 9. Now let's move on. Now I'm going to tell you what prime factorization is. Prime factorization is writing a number as a product of all its prime factors. Let's take an example, 72. 72 can be written as 8 into 9. None of these are prime, so we have to move on. 8 can be written as 2 into 4. 2 is a prime number, so we can circle it. But 4 is not, so we have to move on. 4 can be written as 2 into 2. Again, 2 is a prime number, so we have to circle it. Now that's done. Let's move on to 9. 9 can be written as 3 into 3. 3 is also a prime number, so we can circle it. Now when that's done, we can see that there are 2 3's and 3 2's. So we can write them as 2 into 2 into 2 into 3 into 3. Now we have to check if when we multiply all these, if we get the answer as 72, to check if our calculation is right. 2 into 2 is 4 and 4 into 2 is 8. 8 into 3 is 24. 24 into 3 is equal to 72. So that means our calculation was right. But we can also write 72 as 2 into 36. So here 2 is a prime number, so we can circle it and move on to 36. 36 can be written as 2 into 18. Here 2 is again a prime number, so we have to circle it. 18 can be written as 2 into 9. Again 2 is a prime number, so we must circle it. And 9 can be written as 3 into 3. So 3 is a prime number, so we must circle it. As you see here, we got 2 into 2 into 3, 2 into 2 into 2 into 3 into 3 in both of these, which means both are same. So we have proved that we can multiply any numbers as long as the product is the number above in that tree. In this case is 72. And over here when we did 18, we wrote it as 2 into 9. But we can also write it as 3 into 6. That is also equal to 18. So now let's move on. Now I'm going to tell you guys an application of prime factorization, which is checking divisibility. If For example, if we want to see if 72 is divisible by 12, in the normal division method we would do this. 72 divided by 12. Now we can see that 12 into 6 gives us 72, which gives us the remainder of 0. That means 72 is divisible by 12. Now let's see it in the prime factorization method. As we saw, the prime factors of 72 were 2 into 2 into 2 into 3 into 3. So now here we have to check if any of the combinations of these numbers when we multiply them makes 12, and the answer is yes. When we multiply 2 into 2 into 3, that gives us 12. That means that 72 is divisible by 12. Now we can do 12 into the remaining numbers, which is 2 into 3. That gives us 72. As you see here, the quotient that we got was 6. And over here, when we multiply the remaining numbers, we get 6, which is equal to 2 into 3. Not only did we find if 72 is divisible by 12, but we also found the quotient of the number. I'll see you guys in my next video. Bye.